For years, Florida's wildlife officials have been locked in a losing battle against one of the most destructive forces the state has ever faced: invasive species. From pythons swallowing deer whole in the Everglades to feral hogs tearing through farmland, every strategy deployed seemed one step behind nature's chaos. So when a small, quietly funded research team proposed a radical idea, introducing a specially monitored group of honey badgers to help restore balance, the public reaction was immediate and explosive. Critics called it reckless. Commentators mocked it as Florida's wildest idea yet. Memes spread faster than scientific explanations ever could. After all, the honey badger isn't just another animal. It's one of the toughest, most relentless creatures on the planet, famous for its fearlessness, aggression, and near indestructible nature. No one believed the plan would work. Many were convinced it would make things worse. But over the next 2 years, something happened that no one expected. Not wildlife biologists, not ecologists, not even the team behind the proposal. What unfolded turned into one of the most surprising wildlife management stories in modern history, and it left experts stunned, speechless, and rethinking everything they thought they knew about ecological strategy. Before we uncover what really happened, hit subscribe and tell us in the comments what you think Florida was hiding. The truth is stranger than anyone imagined. Florida's Wildlife Command Center had seen its share of unusual emergencies, but the reports arriving that morning were different. Rangers described patterns they couldn't explain, pockets of silence in places that were normally turbulent with invasive activity, and sudden movement shifts across the Everglades. The tone of the messages drove officials into an unscheduled meeting, one that began not with answers, but with a quiet, uneasy question. Had something finally changed out there? To understand what sparked the alarm, the story rewinds several years to a moment that many experts would prefer to forget. Back then, someone had suggested an idea so strange it became the target of late-night jokes, online memes, and professional ridicule. Florida, overwhelmed by decades of ecological imbalance, was struggling to contain one of the largest invasive species crises in the United States. Burmese pythons were swallowing entire deer populations, iguanas multiplied across suburban neighborhoods, cane toads left poisoned predators scattered across wetlands, and feral hogs continued carving through farmland like living plows. Every year, the damage grew worse. Amid the brainstorming sessions at the Florida Wildlife Research Institute, a small team of researchers explored unconventional solutions. Predator pressure models were tested, population simulations were built, and behavioral studies hinted at the possibility of using a natural counterforce rather than relying solely on traps, chemicals, or human intervention. That was when someone first brought up the honey badger, a creature known for its resilience, resourcefulness, and nearly fearless temperament. It was not a polished proposal at that point, just a bold hypothesis buried among stacks of policy notes. The reaction was swift. Senior biologists dismissed the idea as wishful thinking. Committee members laughed it off during early hearings. Critics nicknamed it Florida's wildest idea yet, and argued that introducing such an unpredictable animal would solve nothing. The plan was rejected, revised, and rejected again. Even the researchers who had originally floated the idea began to question whether it belonged anywhere outside a theoretical exercise. Still, the concept refused to disappear entirely. It lingered in quiet conversations after meetings, resurfaced in internal reports, and returned whenever traditional strategies failed yet again. The honey badger, once a joke, had become a symbol of how desperate the situation had grown. And now, with strange field observations emerging years later, officials found themselves wondering if the idea they once mocked had uncovered something far more significant than anyone expected. Long before the honey badger concept was revisited, Florida's ecosystems had been pushed into a slow, grinding crisis. The trouble did not begin overnight. It unfolded over 4 decades as a series of small disruptions accumulated into a full ecological emergency. Species that once shaped the rhythm of the wetlands began disappearing, replaced by aggressive newcomers that quickly dominated everything around them. Rangers spoke of waterways that felt hollowed out, places where familiar sounds vanished and the balance of life slipped further from what longtime researchers remembered. During these years, biologists found themselves caught between shrinking budgets and expanding problems. Trap and removal programs struggled to keep pace with the explosive spread of pythons. Drone surveys revealed new burrows and nests faster than teams could respond. Chemical deterrents showed inconsistent results, and relocation strategies often failed outright. Internal emails from the period describe frustration more than progress, with one wildlife officer writing that fighting invasive species felt like trying to empty a lake with a teaspoon. Under mounting political and environmental pressure, senior officials demanded new ideas, anything that could slow the decline. Early experiments tested modestly controlled predators, limited mechanical methods, and advanced monitoring technologies. None delivered the breakthrough they hoped for. Yet buried in these experimental logs were notes from a small group of researchers who continued exploring an unconventional direction. This team eventually formed the core of the reassessment. Dr. Lysandra Hale, known for her predictive modeling work, field ecologist Miguel Vasquez, who spent years documenting python expansion through the Everglades, and several ranger units who had witnessed the transformation of the wetlands firsthand. Together, they revisited the earlier hypothesis that had once been dismissed, using a natural, highly adaptable predator as a counterforce. Their reconsideration was not based on enthusiasm, but necessity. The environmental projections had grown grim. Models warned of irreversible losses to native species if nothing changed. In this atmosphere of urgency, even unlikely ideas demanded attention. To test the concept safely, the team created controlled enclosures in remote sections of South Florida, isolated habitats designed to study limited interactions between honey badgers and the local environment. The trials were meant to be purely observational, nothing more than a structured behavioral study. But as the first weeks passed, field researchers began noting subtle irregularities. The honey badgers interacted with their surroundings in ways that did not match previous studies or documented behavior. Staff logged unexpected interactions and patterns that hinted at something beyond simple predation. Though the observations were small and easily overlooked at the time, they marked the earliest sign that the once mocked proposal might hold more potential than anyone had imagined. As the field trials expanded beyond their initial enclosures, the tone of ranger reports began to shift. At first, the observations seemed minor. A few quiet zones in areas typically busy with invasive predators, a missing python nest that should have been active, or the sudden reappearance of small mammals assumed to have vanished from the region. But as these notes accumulated, a pattern emerged that no one could easily explain. Wildlife officers described stretches of marshland that felt unnervingly still, as though something had pressed pause on the usual chaos of the Everglades. Some of the most surprising sightings involved species long believed to be pushed out by invasive competitors. Marsh rabbits, certain wading birds, and even small reptiles were observed in places they hadn't been recorded in years. Their return was encouraging but puzzling. No official intervention had been made in those sectors. The timing seemed too precise to be coincidence, yet researchers avoided drawing conclusions. Meanwhile, the honey badgers themselves began behaving in ways that challenged existing knowledge. Instead of maintaining small territories, several began moving in looping paths that extended far beyond predicted ranges. These movements appeared deliberate, not aimless wandering, yet they didn't match any known migratory pattern. Field teams described the routes as structured but unreadable, like the animals were responding to signals no one could identify. Internal memos written during this period reveal a growing sense of unease. Certain reports referenced behavioral anomalies requiring immediate review, though few details were included. Redactions, unusual for ecological documentation, appeared in several of the compiled assessments. Portions of data charts were blacked out without explanation, fueling speculation within the research group that something larger was unfolding, something the early models had not captured. Remote trail cameras offered their own clues. Footage showed honey badgers confronting invasive species with startling boldness, standing their ground against adult pythons, disrupting feral hog foraging groups, and even interacting with cane toads without succumbing to their toxins. None of this aligned neatly with the controlled behavior observed during the first trials. The animals seemed to be adapting faster, pushing boundaries in unexpected ways. Privately, some scientists began voicing questions they knew would be difficult to raise formally. Were the badgers responding to environmental pressures more effectively than predicted? Had the trials triggered a chain of competition responses across the wetlands? Or was the behavior a sign of another influence, something still hidden within the shifting dynamics of the Everglades? Though no consensus formed, the unease was unmistakable. The once dismissed idea had moved into territory no one could fully interpret, and the silence appearing across sections of the wetlands suggested that whatever was happening, it was far from ordinary. As weeks turned into months, the field teams monitoring Florida's unconventional predator experiment began noticing changes that stretched beyond anything they had anticipated. At first, the shifts were small enough to overlook, isolated observations that could easily be attributed to seasonal cycles or chance. But as the reports accumulated, a deeper disturbance in the ecosystem became impossible to ignore. Patterns that had held for decades were suddenly reshaping themselves with a speed that outpaced even the most aggressive wildlife models. Predator-prey cycles, once predictable in their imbalance, started moving in unexpected directions. Entire stretches of marshland that had been dominated by invasive pythons showed abrupt declines in nesting activity. Rangers discovered abandoned dens scattered across the wetlands, some marked with claw scars and signs of conflict so intense they were difficult to categorize. The pythons had not simply been disrupted, they were relocating, abandoning territories they had held for years without any known environmental trigger. Drone teams conducting nighttime surveys began recording something even more unusual. Instead of the solitary, opportunistic movement honey badgers were known for, the footage revealed clusters of individuals navigating the wetlands with an uncanny sense of coordination. Their paths intersected and diverged with a rhythm that suggested intention, not randomness, as if they were responding to the landscape in a way biologists had never documented. The footage raised more questions than answers, and the research team struggled to interpret behavior that didn't align with established field literature. At the same time, species long considered locally extinct or nearly extirpated began resurfacing across the region. Sightings of marsh rabbits increased. Limpkins reappeared in areas where their calls had been absent for decades. Even small amphibians, highly vulnerable to invasive predators, started returning to shallow wetlands, once dominated by pythons and cane toads. For many field researchers, these discoveries were quietly celebrated, signs that the ecosystem might be recovering in ways Florida had not seen in years. But the enthusiasm quickly met resistance. Senior ecologists were divided. Some dismissed the changes as statistical illusions or temporary fluctuations. Others argued that the honey badgers were acting as a catalyst in the food web, accelerating natural balancing forces that had been suppressed for too long. This predator-catalyst effect, as a few called it, remained unproven, but the data emerging from the field made the hypothesis difficult to ignore. Still, the state hesitated to make any public announcement. Too many variables remained uncertain, and the consequences of releasing incomplete information were unpredictable. Teams were instructed to compile their findings with caution. Internal reports expanded with redactions and annotations. Discussions took on an increasingly cautious tone, reflecting an unspoken worry shared by the scientists. If the ecosystem was truly shifting at this pace, what would the long-term outcome look like? And was the honey badger plan guiding that change, or merely revealing forces that had been waiting beneath the surface? In the absence of clear explanations, one thing became certain. Whatever was unfolding in the wetlands no longer resembled a controlled trial. The landscape itself seemed to be reacting, adjusting, and reshaping in ways Florida's own experts struggled to interpret. By the time the final reports were prepared, the quiet uncertainty that had followed the early trials had shifted into something far more serious. The evidence collected from months of fieldwork, drone footage, ranger observations, and ecological modeling pointed to a conclusion no one involved in the project had expected. Florida's once mocked honey badger plan had produced results that defied conventional wildlife science, forcing even the most skeptical experts to reconsider what they thought they knew about predator dynamics. When the state finally compiled a full disclosure of the monitored release program, the scope became clear. A limited number of honey badgers, far fewer than the public would ever guess, had been strategically placed in isolated sectors across South Florida. Each area had been chosen based on high invasive species pressure, low presence of native predators, and long-term habitat data. The monitoring team expected modest results at best, a few disrupted python nests or localized behavioral shifts. Instead, the animals expanded into adjacent micro-territories with remarkable precision, forming a lattice of overlapping ranges that pressed against invasive populations without causing ecological instability. What stunned the scientists most was not the impact alone, but the way the honey badgers seemed to adapt. Their movements reflected patterns far more structured than previously observed, as if the species were responding collectively to the environment. Camera footage documented behaviors that challenged long-standing assumptions. Cooperative pursuits of large prey, coordinated disturbances of hog groups, and defensive formations around vulnerable native species. These were not the isolated, fiercely independent instincts described in field literature. They suggested a form of strategic behavior researchers had never seen. The cascading effect across the ecosystem was even more extraordinary. Invasive species declined in key corridors, but instead of collapsing the food web, native species quickly expanded into the newly opened niches. Marsh rabbits increased steadily. Limpkins repopulated stretches of wetland that had been silent for years. Amphibians returned to their breeding sites in measurable numbers. Biodiversity indicators, which had been dropping for decades, began reversing at a pace some experts privately described as unsettling in its speed. Internal documents circulated among senior environmental officials revealed the depth of their astonishment. Many admitted the recovery looked less like a simple predator introduction and more like a chain reaction, a pressure shift that allowed the ecosystem to correct itself faster than any model had anticipated. Some reports compared the effect to removing a blockage from a river, allowing natural forces to resume their course. These findings forced wildlife agencies to reconsider long-standing strategies around invasive species control. The experiment demonstrated that targeted predators, when carefully monitored and strategically placed, could influence ecological dynamics far more profoundly than previously believed. International conservation groups took notice, requesting access to Florida's data as they faced their own escalating crises. Yet, despite the optimism, one question remained unresolved. Even after reviewing months of footage and behavioral logs, biologists could not fully explain how the honey badgers learned to operate with such coordinated efficiency. The species was known for resilience and ferocity, but not for the kind of collective adaptability displayed throughout the wetlands. Some researchers believed the animals were simply responding to environmental pressures in ways science had never documented. Others argued that the Everglades itself, shaped by decades of imbalance, created conditions that accelerated the animals' responses. Whatever the explanation, the results stood on their own. Florida's unlikely plan, once laughed at across conference tables, had reshaped an entire region. And to this day, the lingering mystery of how the honey badgers achieved it continues to challenge the assumptions of wildlife biologists around the world. As the dust settles over Florida's wetlands, one truth remains impossible to ignore. Whatever unfolded out there was far more than a wildlife experiment. It challenged long-held assumptions, exposed the limits of ecological prediction, and reminded scientists that nature still guards secrets no model can fully capture. Whether the honey badgers acted on instinct, adaptation, or something we've yet to understand, their impact reshaped an ecosystem once believed to be beyond saving. And for many researchers, the real shock isn't what the animals did, it's how quickly the Everglades responded. But this story is far from over. Field teams are still documenting strange patterns, still arguing over unexplained cooperation, and still trying to piece together how a plan once mocked as foolish ended up rewriting modern conservation playbooks. If you've followed this journey with curiosity, stay with us. More mysteries are emerging from Florida's wilderness every month, and each one raises new questions about the boundaries of science, instinct, and survival. Until then, thank you for watching, and keep your eyes on the wild. It often knows more than we do.